Hello, we're back with section 7.4. So part C, we have 3x over x plus 1 equals 12 over x squared minus 1 plus 2. Now, before I can find the LCD here, I do need to factor one of my denominators. So this does become 3x over x plus 1 equals 12 over x plus 1 times x minus 1 plus 2. So now I can see that my LCD is x plus 1 times x minus 1. So now I'm going to multiply everything by that. The x plus 1's cancel out here, and both the x plus 1 and x minus 1 cancel out there. And now I'm going to distribute. We get 3x squared minus 3x is equal to 12. And then this, just because that's how we factored x squared minus 1, I know this equals x squared minus 1 when I multiply them together. And then I have to distribute the 2 into there. So we get plus 2x squared minus 2. And now I'm going to subtract 12, add 2, and subtract 2x squared from both sides in order to get 0 on one side. So you get x squared minus 3x minus 10 equal to 0. Factor this, we get x minus 5 times x plus 2 equal to 0. That means x minus 5 equals 0, or x plus 2 equals 0. So we get x equals 5, or x equals negative 2. And again, when I plug these into the LCD, neither of them make equal to 0, so both of these are correct solutions. Part D, 2 over x plus 2 plus 4 over x minus 2 equals x minus 1 over x squared minus 4. Again, I need to factor one of the denominators before I can find the LCD. Let me put a line down right there. So we get 2 over x plus 2 plus 4 over x minus 2 equals x minus 1 over x plus 2 times x minus 2. And then I'm hoping you can see the LCD is just that then. X plus 2 times x minus 2. Multiply everything by that. Then we get an x plus 2 to cancel out here, x minus 2 to cancel out here, and then both the x plus 2 and x minus 2 cancel out there. We get 2x minus 4 plus 4x plus 8 equal to x minus 1. First thing I notice here is I have no squared terms. So this is actually a linear equation. So I'm not going to use the zero product property to solve this equation. Instead, I'm going to try to get my x's on one side, my constants on the other. So I'm going to, well, let's combine like terms first. So we get 6x plus 4 equals x minus 1. So subtract 4 from both sides and subtract x from both sides. Get 5x equal to negative 5. Divide by 5, divide by 5, we get x equal to negative 1. And again, if I plug that into the LCD, it does not make it equal to 0. So this is a correct solution. Example 5. Consider the rational function f of x equals 2x minus 6 over x squared minus 8x plus 15. Find the domain of the function. So remember, the domain is when the denominator does not equal 0. So we're going to have x squared minus 8x plus 15 cannot equal 0. Going to factor that, and we get x minus 3, x minus 5 cannot equal to 0. which means x minus 3 cannot equal 0, and x minus 5 cannot equal 0. So our domain in inequality notation is x cannot equal 3 and 5 if we add 3 and 5 respectively to solve those two inequalities. And then in interval notation, that would be negative infinity to 3, union 3 to 5, union 5 to infinity. Again, don't forget this middle interval, because all we're saying is x cannot equal 3 or 5, so it can equal the numbers between them. Solve f of x equals 1. Well, f of x is 2x minus 6 over x squared minus 8x plus 15. So I want to figure out when does that equal 1. Well, the LCD is quite obvious because there is only one denominator, so that has to be it. So I'm going to multiply by the x squared minus 8x plus 15 on both sides. It cancels out on the left-hand side, and we're left with 2x minus 6 is equal to x squared minus 8x plus 15. Because of that squared term, I'm going to use the 0 on product property. So I'm going to subtract 2x and add 6. So I get 0 equal to x squared minus 10x plus 11, which factors as x minus 1. Ah, there's my mistake right there. That should be a 15, so this should be a 21. So then this factors as x minus 3 times x minus 7. So that means x minus 3 equals 0, or x minus 7 equals 0. So we get x equals 3, or x equals 7. Now, since I know the domain, it cannot equal 3 or 5. That tells me, without me having to plug it into the LCD, that 3 will not work, so that's an extraneous solution, but 7 is an appropriate solution. Part 3, solving for a specific variable. Many formulas used in business, science, economics, and other fields use rational equations. Recall, when solving an equation for a specific variable, we treat any variable other than the one we're solving for as a constant that can be manipulated as such. Solve the following equations for the specified variable. Be sure to check for any extraneous solutions. So we have 1 over a plus 1 over b equals c, and we're solving it for a. To solve for a, the first thing I'm going to do is get rid of the fractions. So the LCD here is AB. So multiply both sides by AB. So the A cancels out there, the B cancels out there, and we're left with B plus A equals ABC. And now, because I want to solve for A, I'm going to subtract A from both sides. And get B equal to ABC minus A. Now I can factor an A out of that right-hand side. Get BC minus 1. Then I can just divide by BC minus 1. So I get that A is equal to B over BC minus 1. Same thing here. I'm going to get rid of the fractions first before I try solving for y. The LCD is 3xy. So I'm going to multiply both sides by 3xy. So then the x cancels out here, 3 cancels out here, the y cancels out there. So we're left with 6y plus xy equals 3x. The y's are already on the same side, so I just factor that out. Get 6 plus x equal 3x, and divide by 6 plus x on both sides, and we get y equals 3x over 6 plus x. And that's it for section 7.4.